Now, today I want to finish off the stuff we were doing on Git the last day, and then I want to move back to the topic of automated testing. So I'm just going to go back to the slides that I was looking at there last week, where we were talking about the this branch edit merge workflow, and we talked about creating branches and how they were represented internally in the Git repository. And then we went on to talking about merging and the two scenarios that can arise when you merge a branch back into the master branch and all that stuff. So don't need to go back over all that again, hopefully. And I think roughly where I left off was on this slide here, where I was making the point that and the word is should here rather than can't, you should try and avoid making edits or adding new files to your project when your working directory is aligned with the master branch, or in other words, when the current branch is the master branch. It's just considered kind of bad practice. Now, to be truthful about it, we all fall into the trap of doing that. But what I'm trying to get across is that you should develop the habit of, if you want to start off doing some work on a project, the very first thing you should do is create a branch for that work, whatever the nature of the work is. You're developing a new feature, you're fixing a bug, you want to do some experimentation, whatever the nature of the work is, the very first thing you do is you create a branch off of the master and you carry out the work on that branch, and you're doing committing on that branch. And then eventually you decide, do I want to merge this stuff back into the master because it's important to include the code? And that depends on the nature of what you're doing as to whether you should or should not. So that's fine. So I think I would talk my way through this set of points the last day. Always create a branch and then merge that branch potentially back in, irrespective of, and this just about covers pretty much all of the bases really in terms of what kind of work you might be doing on a software project. Now, so that's fine. So you're in this habit of always creating a branch to do your development work. What point am I making? Oh yeah, the point I'm making here is that the set of commits that are on your master branch, in other words, we need to kind of do a git log of all of the commits on the master branch. I'm saying here that really that sequence of commits should give a very clear picture of the history of the project. And it should be clear in the sense that anybody that comes along and reads through the commit messages will get a very good understanding as to how the project evolved over time. And there shouldn't really be any commits on that master branch or in that sequence of commit messages. You try and avoid having commits which are, are kind of cluttering the story of the project, or the evolution of the project. And then ideally, the series of commit messages should be potentially kind of a searchable string of messages. Now, how we do the search is neither here nor there. But if a project manager wanted to see at what stage in the project's evolution did we do X, whether X might be at what stage did we fix a particular bug that was identified by our client, or at what stage did we introduce a new feature into a project. Hopefully there should be a commit message or messages on the master branch, which answers that question. That's the kind of points I'm making here. There's the sequence of messages, commit messages on the master branch now should satisfy these objectives here. That's fine, but this here is what often happens in reality, right? So, okay, I'm about to engage in some work and I create a new branch of my batch master. Let's say I'm developing, it looks like I'm developing a feature here. I create a new branch of the master branch for that feature. That's good. That's my branch edit merge kind of idea. And I do some development work on that feature, and then I commit it. And here's my commit message. And I think in my head now, I think I've actually completed feature X. And then maybe I discover actually I forgot one part of the feature based on the specification of the feature. So I've got to do some more development work and I commit that. And the message is indicating why did I do these edits? Well, I did these edits because of this. Because remember, I said the commit message should always answer the question why. Why did you do these edits? Okay, so this is why. And now I think I've finished the feature, but I suddenly discovered there's actually a bug in my implementation. So I have to fix the bug. And here's the commit message for that. And I think the bug is fixed, and somebody else comes along and maybe tells me actually there's still something wrong with that feature you developed. So I do some more development work. And so these extra commits here, okay, they are truthfully telling the evolution of the development of this feature. But do I really want these commit messages to appear on the master branch? And the answer is no, I don't. Really, all I want to appear on the master branch is the fact that during this period here, I was working on developing feature X. And by the time I got to, here, I have now fully implemented feature X and it's bug free. The problem though is, if I just continue on and I merge this branch into the master, which I'm doing here, these messages are going to appear on the master branch. So how do I avoid that? You can't. I'm not trying to say realistically you can avoid this happening in real life, because this is what happens in real life. You discover bugs, you forget things, you think bugs are fixed and they're not, etc., etc. So how do I avoid, even though this is what actually happened in reality, how do I essentially kind of avoid this stuff appearing on the master branch's commit history? And the answer to that question is to use what's called squashing in Git terminology, where you essentially kind of, as the name suggests, you squash all of these commits. You squash all of these commits into one commit. Even though you've already made the commits here now, I want to squash them up and do that squashing before I merge this branch back into the master. And this is how you do it. So I'm just repeating again here now the stuff that I've done. But before I do the merging, I execute this command here. Now, what that is doing effectively is when I go head ~4 here, remember head is this special pointer that's always pointing at the most recent commit. So when I did this commit here, the head pointer was pointing at the commit associated with this. And the ~4 is saying, roll the head back to by 4 commits, go back 4 commits in the sequence of, in the commit sequence of the branch that you're currently on. So that would mean going back 1, 2, 3, 4, essentially going back to here. But all we're doing is we're rolling the head pointer back to here. All of the work that you did here and here and here, all of those edits that you've made to the working directory they are still present in the working directory. So effectively, it's as if you never did these commits at all. You just did editing, more editing, more editing, more editing. There's no commit. The commits are actually kind of rolled back. So I'm rolling back the head pointer back to by 4 commits, and then I do my staging and committing. And now my commit message is going to be this here. So that means this is the only commit now that is effectively on this feature X branch as far as the Git log is concerned. These other ones have been kind of have been lost. So this commit, it's a nice clear message. The various edits that relate to this commit will be all of the edits that you did up here, which is what I want. And then I can do my merge. So that's this idea of squashing. I don't necessarily think you'll find yourself having to do that. You may or may not. It's up to you. But the overall objective was, how do I avoid this kind of ugly commit messages appearing on my master branch because of the objective I said at the outset? Well, one of the answers is to use this technique called squashing. And you'll do that in this week's lab, as well as the other stuff that we looked at last week in relation to merging and resolving conflicts and all of that stuff. I'm not too interested in this slide, to be quite honest, because, you know, when you get comfortable using VS Code's Git integration, you find yourself, and I think I would have said this before, you find yourself using the command line fairly rarely to do any Git stuff. You just use the controls that are available within VS Code. So I'm actually going to just skip over this. You can read through it yourselves, but right. That's it. That's all I want to cover on the branch edit merge. If I go over to Moodle. So in this week's lab, we scroll down to the lab section. You will be doing 2 labs again this week. One on the, let's see where I have it. You'll be doing 1 lab on the branch edit merge workflow. So that'll be all that stuff I covered last week and that squashing stuff that I was just talking about right now. And you'll also do a lab involving what's called pull requests in, which is a feature available in GitHub. This one you'll have to submit. You won't be submitting this one. I'll talk about this pull requests, or the what's technically referred to as fork and merge workflow. I'll talk about that tomorrow before the lab. Right, so we're not going to come back to version control again. So that's we've covered quite a lot of it, but of course there's lots of other stuff related to version control and Git in particular, which we haven't covered, but that's okay. I want to go back to automated testing, this topic. And whereas previously we talked mainly about unit testing, now I want to talk about end-to-end testing. So the slides I'm going to go through, you'll get here. Just stopped sharing there for a second because I want to change over to a separate set of slides. So just bear with me. Right. Can I just get confirmation from somebody that you're seeing my slides now again? Anybody just want to shout out?
Yeah, we can see them.
Okay, good. Right. End-to-end testing this time. The old name for end-to-end testing was system testing, but certainly if we're doing web app development or mobile app development, which is two topics that, well, is it next semester you're doing mobile app? I'm not sure if you're doing mobile app this semester, but you certainly are doing web app development this semester. And so this term end-to-end testing is very relevant to that type of application. But as I said, historically, this would be equivalent to system testing. And as I would have mentioned before, when you're doing system testing, you're testing the entire application or the entire system as one unit. Okay. So in your kind of traditional application where it had some sort of user interface, and maybe some server-side logic and a database, then you're kind of treating all of that as one entity, and you're testing that as one entity. And certainly that's the model for a web app as well, but it could also be the model for a desktop application or any other type of user-facing application, as we call it. So that's what we're on about here, testing all of this as one kind of entity. I'm trying to avoid using the word unit, but because unit has a special meaning in automated testing, but let's say as one entity. And when we're doing end-to-end testing stroke system testing, because the two terms are interchangeable now as far as we're concerned, then the kind of concerns you have are you're obviously interested in testing the functionality that's being provided by the system stroke application. And you're testing it from the user's perspective. And certainly if there's a user interface part to this application, then your end-to-end stroke system testing is essentially testing the system from the user interface's perspective, which in the case of a web application would be a web browser. You may also be, well, not may also, you certainly will in general also be interested in performance testing. We're not going to look at that area though. Our main focus is going to be on functionality, but performance testing clearly would be a concern as well, certainly for a mobile app or for a web app. Load or stress testing is kind of a variation on performance testing. In other words, does your application perform well under heavy workloads when there's lots of user accessing it? That kind of idea. That's I guess that really is subordinate to performance testing. But we're only going to focus on functionality. Now, when we are talking about, I've certainly switched the title now to end-to-end testing, but that'll be it from here on in, right? Rather than using the old term. But whether it was system testing or end-to-end testing, we talk about this notion of black box approach towards testing. The idea, the analogy is a black box is a box that you cannot see the internals of the box, but you know how to, you can only see the external part, and you know how to provide inputs to this black box, and the black box does something with your inputs and gives you back a response. So you're not concerned with the internal workings of the black box. You're only interested in, well, if I provide certain inputs, will it give me the right output or response? And that's your mindset when you're doing end-to-end stroke system testing. It's very different for unit testing. When you're doing unit testing, you are interested in the internals of the unit, be that a class or a function. You're actually looking at the raw code and making sure that that's working as you expected it to. But in terms of end-to-end testing, no, you're taking a much kind of higher view, if you like, a bird's eye view, if you like, of the application. You don't want to get into the nitty-gritty of looking at source code. So yeah, okay, so that's fine. I'm saying here that you may also be interested in what are called side effects, though. Side effects, a particular example of what I mean by a side effect is if by providing input to your system, stroke black box, it's meant to make, let's say, updates to the database, then you would be interested probably when you're doing end-to-end testing in ensuring that it did make updates to the database. So that's what I mean by a side effect. Now, when we talk about web applications, or indeed native mobile applications, then the fact that there is a lot of asynchronous communication going on behind the scenes, we have to be aware of that, obviously. Ideally, when we're writing our tests, we don't have to be overly concerned about the fact that there is a lot of asynchronous communication going on behind the scenes. We don't want to get bogged down in that kind of stuff. Hopefully, whatever testing tools that we use will take care of that for us, but we still need to be aware of it. And I'm saying here then finally that end-to-end testing or system testing, the assumption is it would have been preceded by unit testing. So that's the assumption. We've done a lot of unit testing already, and we've ironed out a lot of the low-level problems with our code during unit testing. And it's really that it's because there would be a lot of unit testing done prior to end-to-end testing. That's really why we can take this black box approach towards end-to-end testing, because we're no longer looking at low-level code. Now, for sure, if we identify bugs, we will finish up in terms of resolving those bugs in delving into and making edits to our code. But initially, anyway, we're not focused on the low-level code. So moving in specifically towards web apps, because I did say when I started talking to you about this module on day one that we're trying to align this module with the web app dev module, just so that you have a real context for any stuff that I'm going to be covering. So when I'm talking about end-to-end testing, we're specifically talking about end-to-end testing of web apps. And so the user interface for such an app is browser-based. So whatever testing framework we're going to use, it's going to have to be able to work with browsers, web browsers. And when you talk about web applications, clearly you're interested in, is the functionality working? We're going to be interested in submitting forms and all that kind of stuff. That's part of that tends to be web forms tend to be part of any type of web application. Presumably there's going to be lots of navigation available to the user within your app, and so we need to test that all the navigation links are doing what they should be doing. When I talk about flows here, we won't necessarily look at flows, but a typical example of what I mean by a flow is your kind of shopping cart scenario, where you're kind of going through a series of, and when you're doing your checkout, when you're going through a series of screens and checking. So from a testing point of view, you would want to test that the various flows within your application are working as you expect. I mean, arguably that's part of functionality, but I've just made it a different bullet point here. The final one, visual testing, that kind of relates to the whole CSS side of web applications, because you may make changes to your CSS, but nothing has changed from a functionality point of view. But we'd like to be able to test as well the visual changes that have happened to our application, and are the visual changes as we expected. That would obviously be a very important aspect of end-to-end testing. But I'm not going to look at that side of it. We're only going to look mainly at the first three that I've mentioned here. I will mention frameworks that are targeting this area, all right, but other than that, we won't cover it formally. So that's our kind of context. Now I'm going to talk about, well, what tools do we use for end-to-end testing of web applications? And just for historical purposes, I'm saying that traditionally, as in maybe if you go back maybe 5 years, that kind of ballpark anyway, what you would have found in industry is this would be the tool suite that a lot of software houses would be using. And note, Maca and Chai are part of the tool suite. And we know about these already, so that's going to become useful to us. But there was a framework back then called Selenium, which was the dominant framework for end-to-end testing of web applications. However, in more recent years, a framework called the Cypress framework came about, and mainly because it came about because of some weaknesses with the Selenium framework. So we are going to be looking at this framework called Cypress. And fortunately, Cypress does use Maca and Chai internally. So as we will see, the Cypress tests that we write will look quite like the Maca tests that we wrote a couple of weeks ago. So the structure of those tests are going to be the exact same. We're going to have describe blocks, before hooks, it blocks, all that kind of stuff. Cypress, it's an open source project, runs on all operating systems, et cetera, et cetera. So how do we get Cypress? It turns out to be just an npm install. So we simply add it as another package to our web app project. And when you install it, it actually, as well as it providing a library, it also provides a command line tool or a command line interface. And when you run the command line interface for the first time on your project, what Cypress does behind the scenes is it adds some folders to your project. And I'm showing them on the left here. So it adds a Cypress subfolder, and it's in there is where we will put all our end-to-end related testing code. So it's there's no real reason why we should put our tests anywhere else, but that's where the Cypress framework expects to find them when eventually you want to go running your Cypress tests. It goes looking for the Cypress subfolder. And the subfolder has the Cypress folder has some subfolder breakdown. So there's a fixtures folder, and I'm telling you over here that the fixtures folder is where you would put any sample data associated with your tests. So I don't know if you're testing your movies app, which is the web app that you're developing in the web app dev module, you could put sample movie and sample TV data in there. We won't necessarily do that, but that's where they would go. There's a subfolder called E2E, and that's where we actually put our testing code. So there'll be a number of files. You'll have a file in there for each type of testing that you're doing, and the breakdown of the files really depends on the nature of the application. Typically, there might be one file for each functional area of your web app. There might be a file for just navigation only, but certainly there would be one for every functional area. In the language of Cypress, we refer to each test file, or it refers to each test file as a spec, which is presumably short for specification. And that kind of harps back to this point I was making way back about when you're doing testing, you're testing against a specification. Where when we're talking about end-to-end testing now, our specification is really the user specification that we might have put together having consulted with our end users. Anyway, the test files, it refers to them as specs. There's also a support folder, and in there you put any kind of utility code associated with your tests, and we will do that actually. So that's the breakdown. There's also a Cypress configuration file. There are one or two little entries that we need to put into that file, but other than that, we won't go near it that much. Although, as with any open source project, Cypress has lots of plugins that you can use with Cypress. And typically, in order to use a plugin, typically those plugins require you to add some extra configuration to your Cypress configuration for a particular project, and that would tend to go into this configuration file. Now, we are going to be using the Cypress framework to experiment with end-to-end testing for the Movies app, the Movies React app that you're developing in Web App Dev. And that will be in next week's lab. We'll get going on that. But what I'm showing you on the right here is kind of a preview of what we will be doing in that area. So you can see here in the end-to-end folder, the E2E folder of my Movies app project, let's call it. I've got a couple of specs. It looks like I've got a spec that's concerned with testing the favorites feature within that Movies app. This idea of being able to select movies as your favorites and adding them to your favorites page. It looks like I've got another spec which is testing the filtering part of the app, where you can filter the movies by title and by genre. Again, that I guess is just another piece of functionality, and I want to test it. And that's all I have at the moment. Base, with any kind of testing that you're doing, it's common enough to have what we would refer to as a base level set of tests. And the idea being that, well, if the tests in the base level set of tests, if they don't work, then there's no point in checking all the other test cases, So that's why I've got one called just base on its own. We'll come back to looking at this and at the use of Cypress for the Movies app, maybe at the end of this lecture, if I get there. So inside in these files, we will be using, obviously enough, I guess, we'll be using the Cypress library as well as Mocha to structure the code inside here. But Cypress also provides a command line interface, and that's what I'm talking about down here. So there's typically only two commands really that are available to you. The first command is to run a Cypress GUI, and we'll be doing that quite a lot. And the other command is if you want to run all of your tests. So what this command here does is essentially it goes through all of these spec files and runs them individually. Whereas when you're using the GUI, you can control which spec do you want to execute, which set of tests do you want to execute. So you would tend to use the GUI during development while you're developing your application code as well as developing your test code. You would tend to use what's called the headless mode command when you've done a lot of testing and you would just want to run all of them in one go. let's supposing I've got this simple little web app, yeah, and it's your classic kind of to-do app. And so just to explain, although it hardly needs it, the way this very simple app works is here's a text box. And if I type something into the text box and hit enter, then whatever I've typed is added to this list here. So I can just build up my list of to-dos. Let's not worry about these being saved to a database now or anything like that. It's very basic. Okay. And okay, that's a text box. This, let's call this an ordered list from a HTML point of view. Now, supposing I want to test that this very trivial app actually works. Well, this might be an idea of how I would actually write the tests for that. And the first thing we'll notice straight away is we've got those Mocha structures, those describe blocks, it blocks. So I don't need to explain those. So where Cypress kicks in is all this stuff here. These are my what are called Cypress commands. And you could almost work out what each line is doing. It looks like what this line is doing, because remember now, these tests will actually run inside the browser, because the browser is my user interface. These tests actually run inside the browser, and I'll make that point again a little bit later on. So in that context, what this command or line of code seems to be doing is it seems to be getting the browser to navigate to, this domain. In other words, the assumption now is that I've started up my React development server. I've started that up, so my React app is, my development server is there waiting to serve my React app to me. And this is a React app. Let's assume it's a React app. And so the development server is listening on port 3000. So this line here is actually going to cause the home page of my to-do app to appear in the browser. What's going on here is I'm actually getting Cypress to find a DOM element or a HTML element of type input. Now, the only input HTML element in my homepage is this text box here. So the effect of this cy.get is to cause Cypress to locate a text box within what's currently displayed on the browser. And I'm chaining on this part onto that. And what that will do is it's going to type these characters into the text box. So it's effectively simulating what a user might do if they were manually testing this to-do app. So I'm typing these characters into the text box. And if you want to simulate typing a non-alphanumeric character, then you wrap it in curly braces. And so what this bit here means in Cypress is it simulates hitting the return key. And I'm actually doing some more typing, because when I hit return here, based on the behavior behind the scenes, I said to you that when I hit return here, whatever I type here, when I hit return, whatever I type here appears here. And well, what I didn't say, but let's assume that when you do hit return, the text box goes clear after that. And it looks like I'm typing some more stuff. So that's fine. It looks like this test code has created 2 to-dos on my to-do list on the left. What's going on here then is I'm now asking Cypress to get an element of type li on the browser page. Now, each of these is going to be an li element. We know that from our HTML knowledge. As I said to you, this is an ordered list, and each individual one from a HTML point of view will be wrapped in an li element. So this statement here is telling or instructing Cypress to get an li element. Now, there's actually going to be two li elements based on what I've done up here. So this statement here is actually going to return an array of elements that it has found matching this criteria, this selector as it's called. And you kind of maybe work out what I'm doing here is I'm checking to see if the length of that array is, if the length of it is equal to 2. So that's a bit like a standard kind of assertion, I guess, that I'm making here. So that's our first look at Cypress code. And arguably, it's quite declarative. You know, you could nearly work out what it's trying to achieve. It uses a lot of method chaining. Method chaining is just a programming term that I'm sure you've come across, because, you know, get is a method, type is a method, should is a method, and we are chaining these methods on to each other. So, you know, we're calling the get method first, and whatever that returns, we're chaining on the type method onto that. So this method chaining programming style is something that you will see quite a lot when you're reading Cypress code. So it's not a Cypress thing, it's a programming style. Right. So if I just go back again, sorry now. So your it blocks will contain a whole series of these types of instructions, or as Cypress calls them, commands. So each Cypress statement has this structure to it. There's the command part and there's an assertion part. Now, on the previous slide, most of my Cypress statements were just commands. Again, if I just go back, and if I erase, you know, this is a straightforward command. This is a command. This is a command with an assertion. Okay, the other ones are just commands on their own. This is one where there's a command followed by an assertion. So every Cypress statement, I should use that word really, these are all Cypress statements. Every Cypress statement has this structure. It begins with a command part, and then optionally, there's an assertion part chained onto it as well. And we know about assertions from before. Assertions are where you state your kind of expectations around whatever you're testing. If I focus on the command part, so there's a whole suite of commands available to you. And on the previous slide, we've seen only 2 of them. The get one arguably is the one that you would use an awful lot. And we saw the type command as well. And we know what the effect of the type command is. But what I'm saying here is that a lot of the commands, what they're about is they're all about navigating the and interacting with the DOM structure within the browser. Now, we know what the DOM is, hopefully, from all the web stuff that you studied. The DOM is an object representation of the HTML that's currently being displayed by the browser. And these Cypress commands are all about interacting with and navigating the DOM structure, or if you like, interacting with the HTML that's currently being displayed on in the browser window. So, for example, there's the get command, and what you give this command as an argument is what's called a selector. I'll talk a little bit more about selectors in a while, but a selector essentially allows the get command to identify particular DOM elements or to identify particular HTML elements within the page. And there may be more than one match, and that's very important actually. So I'm saying here that what it does is it gets one or more DOM elements. It returns one or more DOM elements as the result, if you like, of the get. And we have lots of examples of that on the previous screen. And if I just go back, sorry, you know, this cy.get, this will only get one element because there is only one text box on the screen, whereas this one here is going to return an array of elements, you know, whatever's down here. There's also the find command, and you give that a selector as well. Where we use find is we use it to chain on to a get. So I'm saying here is that it gets the child DOM element. So if we take the example, let's imagine we've got a web form currently being displayed on the browser screen. And so cy.get form is going to get the outer element of that web form. And let's say we want to pick out a particular drop-down menu or a select element within the form. So we chain on the find command onto that. So the find is relative to the element that has been identified by its preceding command. And the preceding command in our case would have picked out the form element. So really, we're only looking for a select element, which is a drop-down menu within the form. If there are other drop-down menus outside of the form, this won't catch them, if you like. And just to complete it, presumably, if we're looking for a drop-down menu within our form, how do we actually simulate selecting one of the entries on the drop-down menu? Well, there's a select command that does that first. And it looks like we're selecting the one that has medium as the title on the drop-down option. That's find. Click, fairly obvious, I suppose. What the click command does, it's going to simulate the user clicking the mouse button on a particular element. And again, you would tend to use that in conjunction with get or even find. Here I'm using it with get. I want to get a button. Now, let's assume that there's only one button currently on the web page that's being displayed. Otherwise, this particular piece of code won't work. So I'm looking for the button on the web page, and this is going to simulate clicking that button. And depending on what our app does behind the scenes, clicking the button may cause something new to appear on the web page or whatever. There's the equals command. Sorry. The EQ or equals command. What that does is it picks out. I said to you there that sometimes, certainly in the case of the get command, it returns an array of DOM elements. And so if you want to just pick out one entry in that array, the way you would express that is using the EQ command. And you tell it the index number of the element within the array of elements that you're interested in. And so do I have an example? Yeah, so here we go. Let's supposing we've got a number of text boxes on our page that's currently being displayed. So this here is going to pick out all of the text boxes. And here we're saying pick out, because I think it starts at index 0. So this is going to pick out the third one in that array. And this is going to simulate typing something into that text box. So what it means behind the scenes is that in order for you to write your Cypress tests, you're going to have to be very aware of the structure of the web pages that you're testing. That's a consequence of using Cypress, which makes sense, I guess. Cypress doesn't work in terms of coordinates, like you're not moving to a particular coordinate position on the page. What you're doing is you're going to a particular type of HTML stroke DOM element. Right. So they are some of the commands. There's online documentation, obviously, accompanying Cypress. And I'm just showing you a screenshot of the online documentation here. You've got the URL there at the top. And, you know, there's a whole set of commands. We'll only use a small subset of all of the ones that are available to you. We'll certainly use the ones that I've shown you on the screen so far, but we'll use others as well. But you may find it useful to look up this documentation, to use other commands that I haven't mentioned. It turns out now that this Cypress testing is going to be a fairly significant part of the first assignment that I'll be giving you, which I think I'll probably get to talk to you about next week, hopefully. Now, I know I'm running short on time now, so in the case of the get command, and indeed the find command, and some others as well, the argument to those commands, which are really methods, is what's called a selector. And a selector allows Cypress to work out, well, what type of element are you looking for? And the selector can be any one of these forms, right? The selector could be the actual ID of an element. We know in HTML, we can give a HTML element an ID, an identifier. Well, you can actually specify that identifier with the get command if you precede it with the hash symbol. So what this means now is, and we know identifiers have to be unique. So when you're using an identifier as your selector, you're always going to get only one matching element. Hopefully, there may not be an element with that particular identifier. In that case, that would be an error in your test execution, which would probably cause you to go back to look at your actual code to find out, well, why isn't there a particular DOM element with this particular identifier? Because that's what I expected to find on the page. You can specify the CSS class of the elements that you're looking for. And if you do that, then the way you tell Cypress that what you're specifying here is a CSS class is to use the dot character at the beginning of the CSS class name. Thirdly, this is the one that we've seen so far. You can actually specify a HTML tag name. So we've seen that button, input, paragraph, etc. And finally, you can specify if a DOM element has particular attributes, you can specify the attribute value of DOM elements that you're looking at. So for example, here, I'm trying to get across that I'm asking Cypress to find the button where the button has the attribute type and the value assigned to that type attribute is submit. So it's a better way of, it's a more fine-grained way of getting Cypress to pick out a particular DOM element. If you happen to know that the DOM element does have an attribute, doesn't have to be the type attribute, it can be any attribute. If you know it does have an attribute and you know the value of that attribute, then this is how you can express it within a selector. And we tend to use, I think, well, I'm using it here with the tag name, but I'd say you could probably use it with a CSS as well. I'm not certain about that, though. You'd have to play with it. And we've kind of seen that one already, the equals one. So I'm going to skip over that. Okay, that's as far as I got. I think for tomorrow, I will use at least the first hour of tomorrow's lecture, of tomorrow's labs, as a lecture. So it'll be a bit like last week. because I do want to get through this stuff really before next week, so that you have a body of work suitable for assessment in the first assignment that I'm going to give to you. So I'll try and get through the remainder of these slides here on this set of slides tomorrow morning. Okay, we'll leave it at that for now in that case, and I'll talk to you again tomorrow morning. Thanks.
All right, thank you.